Hi, this is Daryl Barnes with BarnesBasics, and I'm continuing a series, a kinematics series that is focusing on a time when I got stung by yellow jacket. So there's a little bit of drama associated with this problem. And what happened in 4A is that I ran about 8.6 meters in a direction of south. And then in 4C, problem 4C, I ran from that point 8.4 meters to the west. And so the focus on this problem right here is what was my net displacement? And so what we're going to do is we're going to locate this value here. What's the net displacement from the starting point? So what we're going to do first, or after the first thing that we just did, is that we're going to, since we know that this graph is going to go down and to the left like this, we're going to make an XY axis right about here. I think this will work nicely. So let's roll with this right here and see what happens. And so what I want is for you and I to place the 90 and the little notch, or it could be that there is a hole in your protractor. So we're going to go just like this, and we're going to make an XY axis, and when we go down a little bit further, we're going to make another XY axis as we proceed. So the beautiful thing about drawing a little picture is we can kind of see where this needs to fit onto our paper. Another thing that I did is I also decided that that 1 meter in my problem was going to equal 3 centimeters on the board. It's important for me to convert 8.6 meters to a value that I'm going to use to measure how long my vector is going to be. I need to do the same thing with 8.4 meters. In both of these factor labels, you can see how meters over meters cancel, how I'm left with centimeters, and that will tell me how long I need to draw my lines. I'm going to start out with the TI84 Plus. So if I click on and hit clear, then I need to make sure that normal, fix 6, decimal, real, degree, and math print are across the top here. So how I do that is I just hit mode, and then I use the nav pad to move down through there, select what I want, hit second and quit to get out of that. When I'm dealing with the TI-Nspire, click on, which is the home key, and let's click home again, and let's go to, we're going to open a data page, or down at the bottom left it has a multiply, divide, minus, plus sign. Let's open that, and what I can see here is I've got 7 pages open from prior problems. So I think what I'm going to do is I'm going to hit Control nav pad up, and what that's going to do is I can hit Control and menu, and then I can just delete all of these pages that I have open for this document. But over Control menu, delete, then I can move it to all these pages. Control menu, delete. I can delete all these. I had 7 pages open. Control menu, delete. There we go. Control menu, delete. Okay, that's cool. Now I think I have a blank page. So let's hit escape. That doesn't work. Let's hit home. All right. Now, basically what happens is when I click this multiply, divide, minus, plus key down at the bottom, I have a 1.1 showing. That's cool. Let's go back home, and then let's go to settings 5 and click that, open document settings. And I want to make sure that I have float 6 degree, normal, and approximate. And so I can just use my nav pad to go down through those, click on them to get the drop down menus, eventually go down, tab all the way with the nav pad down to OK, and click on that to apply those settings. I already have the settings applied, so I'm not going to do it to my own document right now. So let's hit escape, and let's go back to this page in the bottom left. We're not going to use calculate scratch pad, but we're going to use an actual document page. There we go. I'm actually at 1.2, but that's okay. We'll pick this up in just a minute. Let's do this with the TI84 Plus first. So we've hit on 8.6 multiplied by 3, and I got 25.8. I can't write this morning, I'm dyslexic today. 25.8 cm. And for 8.4 multiplied by 3, I got 25.2 cm. So I know that the line from the origin going southward is going to be 25.8, and then the one westward is going to be 25.2. Then I can connect my resultant. Let's try the same thing with the TI-Nspire. 8.6 multiplied by 3, and let's hit enter. 25.8, good to go. 8.4 multiplied by 3, let's hit enter. 25.2, marvelous. Now, the data that I attained in 4A and 4C, it had two sig figs, 8.6 and 8.4. So that's kind of what we're going to keep in mind as we work on this problem and complete it. So I need to measure a line 25.8 centimeters southward, and I want you just for a second to look at this meter stick. Notice that the 0 is not on the end, it's interior. This is kind of tricky, but just remember that sometimes, class, when you use a ruler, you can't measure from the end always, because that's not where the measurement line, the beginning line, is from. And every one of these represents centimeters, so we don't have millimeters showing, so we're just going to have to guesstimate just a little bit. But if I put the 0 on the origin, and if I measure, let's try this, I go straight down along this line, here's 25, 26 would be here, so I need to have a vector that's a little bit less than 26. So there we go, that looks pretty good. So I'm going to put an arrow on that to show that that's a vector. The next thing that I want to do is I need to make another XY axis basically here, so that we're using 90-degree angles all the way through. And I'm trying to figure out how I want to do this. Here's one way to do it. If I put the 90 on that southward vector, and then I line up the notch or the dot, then I can draw westward. Got another XY axis basically. I haven't dropped that Y value down, but I don't necessarily need to. It's okay. The next line is going to be 25.2 centimeters. It begins from the tip of the last arrow. And so 25 would be here, but I want to go 25.2. So I'm going to kind of say that that's roughly 25.2 right there. So here we go. 25.2 all the way to the 0. And, oops. And I'm going to draw an arrow showing that that is vector 2. By the way, this is side A, this is side B, and the hypotenuse is going to be side C. Remember that this is a 90-degree angle. That is kind of important. This is kind of where it gets a little bit interesting and fun. All we have to do last is just connect these two, connect the tip of the last arrow to the origin, and I can measure it while I'm going there too. Looks like it's about 35.6 for me. 35.6, all right. There we go. There's my resultant, and that's going to calculate my net displacement. I got 35.2 centimeters. Now, if I convert that back into meters, why don't we just do it right here? 35.2, we're saying that on this chart, 3 centimeters is the same thing as 1 meter. So all I would have to do is 35.2 divided by 3 would give me the mathematical value of this resultant. Also, it's important to put a dotted line or make this dash to show that this is the one vector that represents these two added together. This is side C. And also remember that this is angle C here, this is angle B, and if this is side A, that's angle A over there. So in our TI-84, we're going to say 35.2 divided by 3, and I got 11.73. And remember, I told you we're going to do 2 sig figs. If we say that it's 11.73 meters, then that's going to round off to 12 meters. That's one of my answers. That's my graphic determination, because we're going to do a mathematical proof here in just a minute to make this bodaciously cool. Well, we would also like to have a graphic angle from the origin. So let's look at that. But first, let's go back to our TI-Nspire. Let's don't forget our TI-Nspire. 35.2 divided by 3. And I got 11.73. That's good. We're good to go there. So to determine the direction, we will take the notch or the dot and place it at the origin and try to make sure that we're lined up every direction. That looks pretty good. And get the 90 on the south right here. Line the 90 up. Like that. Good. And it's a little bit complicated. Actually, man, it's hitting right at exactly at 45 degrees. 0, 10, 20, 30, 40. Here's 50. And there's a line right in the middle. That's exactly 45 degrees. It's kind of not surprising, not really surprising that we would get that, because both of these values are roughly the same. Even though I drew that one a little bit longer, it's actually both of those sides are the same, so it would fit that these would be 45 degree angles. So that means that this angle is also 45 degrees. So that 45 degrees, that is what we get graphically. Okay, very good. Now we're going to do a mathematical proof. I'm going to do that next, and I'm going to move over to here. And so I'll have a little bit of room to do that and not be exactly in the way. The way that we're going to mathematically prove this is with the Pythagorean theorem. We say that c squared is equal to a squared plus b squared. And in this case, side A is 8.6, side B is 8.4. So let's say 8.6 squared plus 8.4 squared. Now, it is true that in this problem, let's look at this once again, that this is 8.6 meters that are squared, 8.4 meters that are squared. That way, when we look at c squared, we can know that when we get the square root of it, we're going to be back to meters, which is our goal. So let's do this. Let's say c is equal to the square root of all that. How about that? 8.6 meters. squared plus 8.4 meters squared. Let's do that. There is a fancy way to do this where you can put this whole entire expression under the radical sign. I think we're going to go kind of basic. We're going to go a little bit more basic. We're going to square both of these, and then we'll take the square root of the sum of those. That'll be a little bit more civilized. So in the TI-84, let's hit clear. 8.6. The x squared button is along the left side. Hit that and hit enter. And I got 73.96. And let's go to 8.4 and hit the x squared sign and hit enter. And I got 70.56. So I would say, to really simplify this, let's just add these two together. I already have 70.56 queued up, and I'm going to add plus 73.96 and hit enter. I got C is the square root of 144.52. I have that. And so I'm going to hit second x squared, that will give the radical, and then second negative, which is the answer, hit enter, and I get 12.02. C equals 12.02 meters. Now, what did I get? I got 11.73 converted over to 12. So not so bad. So we would say this is 12 meters, and then we would say that this is the mathematical determination. So I have a mathematical, I have a graphic angle. I'm missing a mathematical angle determination. So let's do that next. I'm going to remove this information over here so that we can have room to do our mathematical determination of the angle. So to do that, we would say that if we want to know this angle and we have the adjacent and the opposite side, those are given. That's the safest way to do this, not using the hypotenuse, which we just derived. But if we said this, if we said tangent of theta is equal to opposite over adjacent, then we could say that it's equal to this side, side B, which is 8.4, divided by the adjacent side, which is 8.6. That's tan of theta. So we will eventually want to find theta, which is the degree. So here's how we would keep simplifying this. We would say theta, we would divide by tangent. So we would say theta is equal to tan negative 1, or inverse tan of this value, 8.4 divided by 8.6. So we're going to divide this number first and then do inverse tan to get theta. Let's do that. So we're going to hit clear. 8.4 divided by 8.6. Hit enter. And I got 0.976. So 0.976744. We're going to say second tan. That gives tan negative 1. And then let's hit second minus. That pulls up the answer. Hit enter. And I got 44.32. Theta is equal to 44.32 degrees. And if we round it off, we would round it off to 44 degrees. We need a little bit more information than that, but we'll talk about that. TI-Nspire. Home. 8.4 divided by 8.6. Enter. 0.97674. Perfect. It's a little bit different on the TI-Nspire. We're going to hit the control and the, we're not going to hit the control. We are doing a trigonometric function, so we're going to hit the trig key, and we're going to use the nav pad to go over to 10 minus 1, select that, and it'll show 10 minus 1, and then let's hit Control negative, which is the answer, and hit enter. And I get 44.326. I get the same thing. So what we need to kind of think about is, how does your teacher want you to report this? This is north. This is south. This is west. This is east. Does your teacher want you to report your answer in relationship to the x-axis? If he or she does, then we're 45 degrees south of west. That's how we would say that. In this case, mathematically, we would say 44 degrees south of west. Let's circle that. That is a mathematical proof. We could also say, okay, I kind of made a mistake here. This is a common mistake. I determined this angle to be 46. So this angle here, south of west, is actually 46. So let's go back. Let's go back. Let's get this right first, and then we will tweak it. It's 44 degrees west of south. Let's say that. 44 degrees west of south. That's the truth. Then if you want to say something about west, then you can say 46 degrees south of west. See, this angle's 44, this one's 46. We determined 45 degrees. So in our problem up here graphically, we might say 45 degrees west of south. We might say the same thing there, depending on how our teacher wants us to report it. It's possible to also report it in 360 degree. You could go from 0 to 90 to 180 to 270 to 360. You could report it that way as well. So it would be, in this case, it would be 180 plus 46. That would be the resultant. So is that 226? Hope I'm right. Don't want to re-record this. What is 180 plus 46? 226 degrees. That's a possibility too. There are several different ways that this can be reported. So, to summarize, I just was wanting you to find my net displacement from my original attack site. I was stung here. I ran this direction. I ran this direction. What's the net displacement from the original site? What's the answer? 12 meters, 45 degrees west of south. 12 meters at 226 degrees. That sounds pretty good too. Marvelous, marvelous. The next kinematics problem set is going to be a shooting, trying to get a piece of mistletoe out of a tree. So I've got a 5A, B, C, and D coming up on that one as well. We'll have a good time doing that. It's getting to be the holiday season right now, so 'tis holiday season. All right, good job everybody. Marvelous.